Now coming to the properties of alkynes. So alkynes undergoes addition reactions because it is unsaturated hydrocarbon. Alkynes are. So it undergoes addition reactions. So here you will find in case of alkenes we have seen the reactions is taking place in one step because there was one pi bond, that is or one double bond was there. Here you will find that is 3 bonds are there. So definitely first alkynes will break up to form alkenes. It will undergo addition reaction to form alkenes. Then alkenes will break up to form what you can say alkanes. That means in other words I can say alkynes undergoes addition reactions to form alkenes. Alkenes undergoes addition reaction to form alkanes. Got it? So you will find basically that most of the reactions is done in 2 steps. 2 steps in this way. Because alkanes is saturated, it is a stable product. That is a saturated hydrocarbon, that is stable hydrocarbon, we can say that. So hence the reaction is basically done in 2 steps, so to say. Clear? So here you will see the first one is catalytic hydrogenation, like HC triple bond CH plus H2 in presence of nickel and heated. Alright, there the temperature is around 300 to 350 degrees Celsius, already we have discussed. So what is going to happen here? See, one hydrogen will come here and another hydrogen will come here to form what is that? H2C double bond CH2. H2C double bond CH2, you are getting it. CH2 double bond CH2. So ethyne breaks up to form, what you can say, adds up to form ethene. Triple bond breaks to form double bond. Again it reacts with Ni/H2 and heated. What is going to form? CH3 single bond CH3. CH3 single bond CH3. So ethyne to ethene, ethene to ethene. This is addition reactions which is taking place in 2 steps, we can say that. Similarly, if it reacts with halogens, HC triple bond CH plus Cl2 in presence of CCl4, it's an inert solvent. I said earlier also, an inert solvent is required to carry out a particular reaction. It's an inert solvent. Carbon tetrachloride, inert solvent. You can take ether also, you can take chloroform also, or you can take acetone also, an inert solvent. So what will happen? One chlorine will be added here, another chlorine is added here. See, addition reactions in chemistry is taking place in this way. It is not like maths 2 plus 3 is equal to 5, 5 plus 4 is equal to 9. So you need to understand how it is added. One chlorine atom is added here, another chlorine atom is added here. So triple bond gives up to form double bond. So you will be getting HC double bond CH, one chlorine atom is here, another chlorine atom is here. Again it reacts with Cl2 and CCl4. What will happen? That is HC single bond CH, one here, one here, one here and another here, we can see. So in this way we get it 1, 1. What is the name of this compound? This compound we will say first. 1, 2, 1, 2 or 1, 2, anyone you can take. So 1, 2 dichloroethene. 1, 2 dichloroethene, double bond. Here what is that? 1, 1, 2, 2 tetrachloro, 4 chloro you can see, ethane. 1, 1, 2, 2 or you can say 1, 1, 2, 2 tetrachloroethane, we can say that. Clear? In this way. This particular product is being formed in this way. 1, 1, 2, 2 tetrachloroethane, we can say that. Now if you take bromine here. Now bromine, if I take here Br2 here, so what will have? Br, all the Br will be having it. You can take CCl4, no problem. You don't say CBr4, no. You can take CCl4 but Br2. So it will be 1, 2 dibromoethane and here 1, 1, 2, 2 tetrabromoethane you will be getting it. That is not important. The important is that the bromine, the color of the bromine is discharged. What is that? It is brown and it changes to what? Colorless. Alright, bromine is brown. That is, if you take a bromine Br2, let me write here, you will understand it. Br2, then what I am going to get it? Here that is Br, here also Br. Br. Here also same thing, Br, and here also same thing it is Br. And here we will be getting, that is nothing but Br2, we can say that. So 1, 1, 2, 2 tetrabromoethane, which is a colorless solution. It is a colorless solution. When you will pass the brown colored bromine, what you can say, through, that is acetylene. Alright. That is, rather I should say, when you pass acetylene gas through bromine solution in presence of carbon tetrachloride, then you find the brown color of the bromine is being discharged and it becomes colorless. We can say that. This is a test for unsaturation compound. We can say that is the test for unsaturation compound. That means you can see alkenes also give this test. Alright. Alkynes also give this test, as well as alkenes also gives this test. Triple bond also gives a test and double bond also gives a test. Hence it is said to be as test for unsaturated compound. That is alkenes and alkynes both will give this test. But remember it, alkanes does not give this test. So this is a difference between saturated and unsaturated compounds. Note it children, earlier also I have said you saturated unsaturated in alkenes chapter. In alkanes chapter I have said it. Alright, in this way, this is a test for unsaturation compound, or I should say the difference between saturated and unsaturated compounds. In the exams it is going to come. Differentiate between, that is ethane and ethene. You can write this difference. Differentiate between ethane and ethyne. You can write this difference. That ethane does not give this particular test, but ethyne gives. The brown color of the bromine is discharged and it becomes colorless. We can say that. You can discuss it in this way. What you can say, you can write it in this way. Discuss, I'm saying. Now, next is if the reaction is taking place with iodine, alright, Hc triple bond CH plus I2, we can say that. I2 in presence of same thing, you can take here CCl4 or any other inert solvent. I have said you also. Let us take here another one, alcohol, like ethyl alcohol or methyl alcohol. It also acts as an inert solvent. So what will happen here? Hc double bond CH, and here one I and here one I is being added. So 1 2 that is diiodo ethene, 1 2 1 2 or 1 2 whatever it is, diiodo ethene, we can say that ethene is being formed, or ethyl diiodide, the common name is ethyl diiodide. Now you might be thinking that I will be doing the reaction further. No, it is not possible. Why? Because the iodine is a bigger atom, you know that, the bond is weaker. Now further, if at all the reaction is taking place, that is not be a stable compound, because smaller is the bond, stronger is the bond, bigger is the bond, weaker is the bond. We can say that. Smaller is the bond, stronger is the bond, bigger is the bond, weaker is the bond. So iodine atom is a bigger atom. Alright, so the bond also will be big. So this only, it's very difficult to stabilize. If it further reacts, then more to iodine atom will be added, which will make the atom, which will make the molecule more unstable in nature. For that particular purpose, this is your end product, we can say that. Got it? Now, next is if it reacts with the halogen acids, we can say that. Any halogen acids like Hc triple bond CH plus HBr, we can say that. Halogen acids, when it reacts. Alright, what is going to happen? Simply it will be added up. It may make it shorter because I have to write the reactions. Now H will be added here, Br will be added here. So when H is added, CH is there, CH2 it becomes double bond CHBr. So what is the name of this compound? It is known as bromoethene. Bromoethene. Or we can say vinyl bromide. Vinyl. See, from ethene if you remove one hydrogen, it is vinyl. Like from methane if you remove one hydrogen, methyl. Ethane if you remove one hydrogen, ethyl. From ethene if you remove one hydrogen, ethene. This is a ethene, this is double bond, ethene. Ethene is, what is the formula? CH2 double bond CH2. I have removed a hydrogen. So what is that? Vinyl. So vinyl bromide. Now you might be thinking, sir, I have not removed, I have added hydrogen. Yes, you have added hydrogen to ethyne. You have added hydrogen to ethyne, no doubt. But if you see the structure, what is that? CH2 double bond CH. Actually, how did we get CH2 double bond CH? From ethene, if I remove one hydrogen, ethene is what? CH2 double bond CH2. From there, if you remove one hydrogen, then only you will be getting CH2 double bond CH. So that is called vinyl. The name is vinyl. Now, next another HBr if I add it here. Another HBr. So what it will be? Again H will be added here. Not here. Here only. Because this side if you are adding H means here only you will be adding the H. CH3 single bond CHBr2. CHBr2 we can say that. CH3 single bond CHBr2. That is nothing but 1,1 dibromoethane. 1,1 in the first carbon only 2 bromo is there. So 1,1 dibromoethane we can say that. It's an addition product. Same thing it takes place with HCl also. With HCl also the reaction is going to take place. Got it? Now next is we'll see the reaction with ozone. We have done it with ozone. In case of ethene we have done it. Now we will see in ethyne the reactions. With ozone we will see. So it will undergo what sort of reaction? Addition reactions it undergoes with ozone. How it is, let us look at. So with ozone we have seen it in alkenes chapter that when it reacts with ozone, it forms ozonide, and ozonide is highly unstable, it's highly explosive. So as soon as it is being formed, you should immediately reduce it so that it forms a stable product. Got it? Here also same thing, you have to remember it. So here HC triple bond CH plus O3 in presence of any inert solvent, you can take it here, like ether you can take, CCl4 you can take, inert solvent. Then an addition reaction is going to take place. HC, here one oxygen, here oxygen. You need to learn this particular one, I have said you earlier also, you need to learn it. How? Just by counting the bond. See here, carbon, it is how many bond here it is, one more bond will come here. Now carbon 1, 2, 3, 4 bonds, oxygen 2 bonds, carbon 4 bonds here, and hydrogen 1 bond. You need to learn in this manner, then only you will be able to understand the product, how it is being formed. Got it? You cannot mug it up, I am saying you repeatedly. Now this is known as acetylene ozonide. This is known as, which is highly unstable, highly explosive. So as soon as it is being formed, you react with zinc and water, where zinc acts as a reducing agent. You reduce it immediately. So the cleavage is going to take place here and here, here and here. The cleavage is going to take place. So what you get it here? CHO, single bond, CHO. So what is the product I said? CHO, single bond, CHO. See here, CHO, single bond, CHO. And this oxygen reacts with zinc to form either zinc oxide or H2O to form H2O2. Either it reacts with zinc to form zinc oxide or H2O2. What is this oxygen, this particular oxygen? And what is the name of this product? It is known as glyoxal. Glyoxal. This is known as glyoxal, what is said to be as. Or we can say IUPAC name is ethane, 2 carbon, eth, single bond, N, ethane 1,2-dial. CHO is what? Al. Ethane 1,2-dial. Ethane 1,2-dial. We can say that. Clear? Now similarly, if it is reacting with what you can say oxidizing agent like KMnO4, which will give you nascent oxygen. Like suppose if you take here, that is dilute KMnO4, that is cold dilute KMnO4 solution. Now listen that. Very important here. Cold dilute KMnO4 solution is also called as Bayer's reagent. Bayer's, B-A-E-Y-E-R, cold dilute KMnO4 solution. It's known as Bayer's reagent, it is called as. So which gives you nascent oxygen. So you can write it here, cold dilute KMnO4, which gives you nascent oxygen, or also you can write Bayer's reagent. Understood? Here also you can write Bayer's reagent. Remember it, the name. So in this way, what will happen here? It will get oxidized. Alright, it is going to get oxidized. So oxidized means the final product is acid, you know that. You have read it. Alkanes oxidizes to give alcohol, alcohol oxidizes to give aldehyde, aldehyde oxidizes to give carboxylic acid. Same thing here also. Alkynes will oxidize finally to give you what? That is nothing but your carboxylic acid. That is alkyne to alcohol, alcohol to aldehyde, aldehyde to acid. We will be getting it. Clear? So in this way you will be getting one carbon, that is COH, another carbon also COH. What is this called? Oxalic acid. Now you balance it, you see how many oxygen is required? 4, so you write it here, 4 nascent oxygen. Alright? 4 nascent oxygen. In this way you will be getting it. That is oxalic acid, you will be getting it. Cold dilute alkaline KMnO4 solution. If it is simply heated in air, combustion, then it will give carbon dioxide and water. You know that. Any hydrocarbon, when it is heated in air, always gives two products, carbon dioxide and water. You will be getting it when it is heated in air excess. Now next, which I am going to come, there is a test for alkynes. Only alkynes give this particular test. The one which I am going to tell you now. Only alkynes. So this particular test will differentiate alkenes from alkynes and alkenes. That is, alkynes only give this particular test. What is that? If you pass, that is acetylene, through, that is silver nitrate solution, ammoniacal silver nitrate solution, which is called as Tollens reagent. Listen carefully. Ammoniacal silver nitrate solution, which is known as Tollens reagent. You will be getting a silver mirror. You will be getting it. Clear? Or you can say you will be getting a white PPT. You will be getting it, which is known as silver acetylide. You will be getting it. Fine. This is one. Second one is that when you pass acetylene gas through ammoniacal cuprous chloride solution. Cuprous chloride. There is no other name for it. Now you'll be getting a reddish brown PPT, or you can say red PPT also you'll be getting it, which is known as copper acetylite. Copper acetylite, so to say. Got it? Clear? Now let me write the reaction. Then you will be following it. HC triple bond CH plus AgNO3 plus NH4OH. This is known as, this together is known as ammoniacal sylvanitrate solution. Ammoniacal, AMMONIACAL, ammoniacal sylvanitrate solution, or Tollens reagent. TOLLENS, EN apostrophe S, Tollens reagent. What will happen here? This H will be replaced by Ag. So you will be getting it AgC triple bond CAg, which is a white PPT or silver mirror, as I said you. If you heat it, you will be getting a silver mirror. Otherwise, it's a white PPT. So, definitely I require 2 silver. Now, this what you can say, nitrate reacts with ammonium. Ammonium is positive, nitrate is negative. You know, it is going to form what? That is nothing but NH4NO3. And you will get 2 molecules of water, 2 NH4NO3 plus 2 water, because 2 OH is there and 2 H is there. This 2 H and this 2 OH, count it properly. Got it? So in this way, here also 2 I require. So in this way, this is one of the tests. Another, we can write the reaction HC triple bond CH plus CuCl plus NH4OH, ammoniacal cuprous chloride solution. This is called as ammoniacal cuprous chloride. This is silver nitrate, this is cuprous chloride. So what will be happening here? CuC triple bond CCu, which is called as red PPT or reddish brown PPT. Now the name of this compound is copper acetylite. Copper acetylite. This is silver acetylite. Silver acetylite. ACETYLIDE. Acetylite. Plus what you will be getting? Here you will be getting NH4Cl. Now 2Cu. Here also 2. So 2 NH4Cl plus 2 molecules of water. This 2 hydrogen reacts with this 2 OH group to form 2 molecules of water. In this way, this 2 test you can see is given only by acetylene, not by what you can say ethene or what you can say ethane. That means it is given only by alkynes, alright, not by alkenes and alkanes. So this test differentiate between alkenes, alkanes and alkynes. We can say that. Now coming to the uses, it is used to prepare, cut the metals for cutting and welding purposes. It is used because it produces a high temperature. It is used for artificial ripening of fruits and the preservation of fruits. We can say that. It is used in the manufacture of, you can see, acetic acid. We have seen it. Then oxalic acid. Then glyoxal. We have seen it. Or many compounds in this way. We can say that. Manufacture of synthetic products like different polymers. We have synthetic rubbers. You will be reading in higher classes. You will be seeing it. So in this way, this is all about your alkynes. Thank you.